Aha, so welcome back. So, just like we were saying before it went off, before we were cut off, you have to, for you to carry out a proper load analysis, this is what you need to do. You need to do, and you need to take this very serious because that is where the problem starts from. That is where most of our problems start from. If you don't do a proper load analysis, you would have a problem. You have big problem with the client because he will definitely not get the bests, and you will be having issues with him. So now, or you can overestimate him, and if he discovers that you overestimated him, he will be feeling you cheated him. So for you to be on the safe side, it's better to do a proper load analysis so that he gets the best from what he's actually going to spend. So now, the next thing you'll be doing is you need to get the watt hour. Watt hour, that is watt hour. You need to get the watt hour for this particular loads, which is simply gotten by multiplying the wattage times the run hour or the run time. So enter. Once you do that, so I am actually using Excel sheet, but you should understand that this here, the watt hour here is a product of this and this, which gives us this. So if you're using Excel, it's very easy. You just drag it and it will what? It will give you the corresponding values for the remaining rows. So that is it. You have gotten your watt hour, which is what we're actually looking for. So now the next thing is for you to sum up the total watt hour. So if you see here, we have 7,560 watt hour. That is 7,560 watt hour as his daily power consumption. Daily power consumption. So now, what do we do? Which is equivalent to 7.560 kilowatts hour by simply dividing this by 1,000. 7.560 kilowatt hour. So first thing, we've gotten our load. The next thing we should be thinking of is inverter sizing. Inverter sizing. You can easily get your inverter sizing by summing all this load here, this particular column number G. You can get it by summing this. If you sum it, you get 725 watts. 725 watts as the total load, capacity for this particular client. Next thing now is, if I have 725 watts as his energy, as his power, as his power rating, total power rating, what I need to do is, what type of inverter do I need to power this particular client? It's very easy. It's advisable to always take an inverter, to choose an inverter that is twice the size. Sorry, my daughter just woke up. Let me attend to her. Sorry, she woke up and saw herself alone. So she got frightened. So I'm back. So what happened is, so it's always wise to choose inverter that is twice the size of your rated power. So in this case, we have 720, 725. So who can suggest an inverter capacity that will be twice the capacity, twice the power capacity, power rating of this guy? Who can suggest an inverter, please?
1.5 kilowatts.
Okay, 1.5 kilo. Okay, that's good. 1.5 kilowatts of an inverter will be the best to give this guy, to power this guy. So we have gotten our inverter capacity, needed inverter capacity. Needed inverter. We know that not all these loads will be on at the same time, but it's always good for your inverter system to work minimally so that it doesn't become, when it works, when it is outstretched and it works for a long time, definitely it will affect the longevity, the lifespan of that inverter system. So it's always good to give that that room so that it doesn't work, it works effortlessly. So that is that. We've gotten our inverter, desired inverter capacity. So fine. Now next, our load, we've already gotten our daily load consumption, which is 7.56 kilowatt hour. Now, we are now, okay, depending on it, then the next thing you'll be discussing with your client now is, I have gotten this thing. I've gotten your daily load consumption. Now, I want you to choose the type of battery you want me to use for your project. Do you want a lead acid battery? Do you want a lithium ion? Do you want a tubular? You will now tell him each and every one has advantage. Each one you now tell them the advantages, or tell him the advantages and disadvantage of each of these battery types. The lithium, it's good. It has a longer lifespan. It has a good energy density. It will not occupy a space. It will not occupy, it doesn't occupy space, but it's expensive. That is the disadvantage. That's number one for the lithium. For the lead acid, it's cheaper. It has one or two, it has lower lifespan, or shorter lifespan rather. It has quite numerous disadvantages compared to the lithium ion battery, but the advantage is cheaper than the lithium ion. So it all depends on how you, depending on the capacity of the client or what the client wants. I have met clients that will tell you that they want to install this inverter and they don't want to, they've actually planned, for it so that it becomes a long-term project. They don't want a situation whereby after 2-3 years you tell them that the batteries have gone bad. They want a situation whereby it should run for 10 years because they have actually planned that it should be like that. You understand? So it all depends on the client. Some clients have the money to spend and they want the good thing. They want a longer, something that will serve them longer. It's not that the lead acid is bad. It's not like the lithium ion is excellent. You understand? The thing is this. It's actually, each one of them has its own advantages and disadvantages. So it all depends on who is involved. So fine. If the client decides that he wants a lithium ion battery, for example, you can just go to the market. The lithium ion batteries are rated in kilowatt hour. For this particular load sizing, we have 7.5 kilowatt hour. So you can go to the market and say, okay, where can I get a 7.5 kilowatt hour battery? Lithium battery. You can get it. It's very easy. So you can just get one for this particular project. The next thing is, if the client says he wants sealed lead acid batteries. Okay, you want a sealed lead acid battery. Okay, we have the numerous in the market, numerous type in the market. We have two broad types in the market. Then we have two broad types in the market. We have the tubular one. We then have the, let me not use the word sealed lead acid, sorry. lead acid battery. The still lead acid battery is the maintenance free. So let me use the word lead acid battery. The lead acid battery has two broad classification. We have the tubular or the SIL SLA or the maintenance free still lead acid. So it all depends on which one he wants. If he doesn't, if he's somebody that says, okay, I don't want any maintenance, you understand? I want a battery that when it's installed, no, should just serve me, no maintenance. I don't require maintenance. That doesn't require maintenance. You can give him the still lead acid. If he's somebody that wants the lead acid, but wants doesn't he said he's not concerned about maintenance. Maintenance can be carried out from time to time. You can now decide to give him the tubular type of batteries. Each one has its advantage and disadvantage. The tubular batteries actually will serve longer than the sealed lead acid batteries. The tubular batteries serve longer than the only thing is you need to be doing a little maintenance on them. So those are the things. So now we've talked about now a 7.5 kilowatt load. What quantity of lead acid batteries do I need to get up to this power storage? What quantity of lead acid battery do I need? You know, normally the lead acid battery come in 12 volts. 12 volts, 100 ampere hour, 12 volts, 200 ampere hour, 12 volts, 150 ampere hour, and so on. So what quantity of battery of the 12 volts battery, lead acid battery, do I need to get this particular energy stored? Fine. Let's look at a typical, let's look at a lead acid battery now. So we have, it comes, let's say, okay, we want to use a 12 volts, 200 ampere hour battery. 12 volts, 200 ampere hour battery of the lead acid battery. Now, each of those batteries, we have to get how many kilowatt hour can we get from each of these batteries? It's gotten very simple by multiplying 12 by 200, which you will get 12 times 200, 2,400, right? 12,000.
P is equal to IV power, right?
Yes. Yes.
From the formula.
Yes. So VA now, that's the V in the voltage, and the A in the battery will give us the watts, while the hour will be, that is why we have now 12,000 and 2,400 watt hour. I don't know if we get it, please. It's just an elementary mathematics, sorry. The 12 volts and the 200 ampere hour, that is the rating of the battery. So if we want to get the required AH or watt hour, or if you want to get the required watt hour rather, you simply multiply the 12 volts by the 200 ampere hour. We've gotten 2,400 watts hour. Fine. These lead acid batteries also have what we call depth of discharge, please. Depth of discharge. These batteries have what we call depth of discharge, depending on the type of the battery or the make, but it's always good to know the depth of discharge of a particular battery you're buying. Some are 50%, some are 60%. I learned there are some that are even up to 70, but mostly, majorly, what I've seen is between 50 and 60% depth of discharge. For you to enjoy these batteries, for you to get the best out of these batteries, you have to work within this depth of discharge. You understand the point? You have to work within this depth of discharge. If you are installing the inverter, you have to configure it. If you look at, okay, if you look at these batteries, when you buy them, they have their technical details on them. You understand? They will tell you the operating voltages, maximum operating voltages from 10.5 to this. So you have to go to your inverter setting and ensure that these things are, your inverter is configured like that. If not, you know, the lead acid battery doesn't have a protection. It doesn't have a battery monitoring system. So if you continue to drain it below the maximum or below the maximum operating voltage ranges, then it means you will definitely have issues with the battery lifespan. It will definitely affect the battery lifespan. You understand? So each battery has its own depth of discharge. So if this battery is rated to have 60% depth of discharge, you need to confirm all these things, please, when buying these types of battery. You need to confirm this battery, okay, it has 60% depth of discharge. Then it means for this particular 2,400 watt hour that we've seen here, we are only going to get 2,400 times 0.6 if that is the usable power. That is if the battery has a depth of discharge of 60%. If it's 50%, we multiply it by 0.5. So for this particular, let's assume this particular battery we're looking at has a depth of discharge of 60%. So please, somebody should multiply 2,400 by 0.6 so that we know what we are getting from this particular battery. So what are we getting from this battery, please? No response? Are you with me?
We are with you.
Okay, 2,400 times 0.6. I got 1,440 for this particular battery, right? 1,440 watts hour is what we're
Yes.
going to be getting from this battery. So 1,000.
Sir,
Hello.
Mr. Vella,
Yes, boss.
I think you should be multiplying with 2,640, not 2,400. 12 times 2. Okay, you're using 200 amps.
Yes, 200 amps, sir.
Okay, not 220. Okay.
Yes,
Sorry.
no, we're just looking. Okay, we just gave okay, sorry. So now
Okay.
we got 1,440 watts hour. That is the total energy we can store and get back from these particular batteries. So in this this case, in this particular load here that we were talking about, this particular guy or this particular client needs 7.560 kilowatt hour of stored energy for him to be used daily. You understand? So now, what do? We simply divide 7 to get the number of batteries. If we're going for, we talked earlier of the lithium ion. The lithium ion are rated directly in kilowatt hour. You go to the market, you say you want 7.5 or you want 10 kilowatt or 8 kilowatt, you get it directly. But for the lead acid battery, you are going to be the one to determine the quantity you need from the calculations. So you now do this divide by 1,440. So which we've gotten 7,560 divided by 1,440. So we have 5.26. 5.25 rather. So 5.25 what is what we've gotten. So that is the number of batteries we are going to be using on this project. So 5.25, batteries are discrete integers, Abi. What do we call them for the mathematicians? It's a whole number is an integer. Well, right? I don't know. I'm trying to, or let me,
Yes.
it's an integer. Good. So it's an integer. Battery
Yeah.
definitely has to be an integer. That is number one. So 5.25 we know will definitely not work. We have to find a way of rounding it up. You understand? So, but another thing we also need to look at here now in this case is these batteries come in 12 volts. You understand? Our inverter, we said a 1.5 kilowatt inverter. So this 1.5 kilowatt inverter now, what does it accept as its input voltage? Is it a 24-volt system? Is it a 12-volt system? You understand the point. Is it a 48-volt system? You have to, all these things has to be tailored around what is available in the market. It has to be tailored around what is available in the market. So now you have to, okay, I know that I need 1.25 kVA of an inverter, or kilowatts of an inverter. Okay, I know it's, okay, that is that. So now I'm having 5.25 batteries as what I need to back up this my load. Do I have 1.5 kVA coming in 48 volts or 24 volts or whatever? It's, you now look at it as an engineer, you now look at what do you do? Mostly 1.5 kVA or kilowatts, 1.5 kilowatt inverters come in 24 volt system. They come in 20, they accept 24 volts, the ones available in the market. It's of recent that we're seeing 1.5 coming with 12 volts. Are you with me? But I still don't like the idea, because once the voltage goes low, that means it means have to be handling a lot of current to get the desired power. You understand? You have to be I don't too like the idea of an inverter with a high capacity coming with a lower voltage, because you have to be handling a lot of current on the battery side of it. I don't know if you understand my point. It's better to have a higher voltage, then the current now reduces, so that you'll be handling less amount of current in the on the battery part of it. So you understand, it's all, these are the things you need to know when you talk of, okay, assuming now you talk of, we are talking of a 1.5 kVA system, 1.5 kilowatt system, 1.5 12 volts kilowatt system. If we go for a 12 volts kilowatt 12 volts inverter system, what we will be handling is, we will be handling twice the amount of current, when the current will be 2 times more than when we are handling a 24 volt system. So those are some of the things you need to be looking at. You understand? Me, I prefer, and I always advise, it's better to have a higher voltage. Since in this case we are dealing with from our calculation, we are looking at 5 batteries. You understand? 5 batteries, right? 5 batteries. We're looking at 5 batteries, since we said, okay, it's 5 batteries. Okay, if we're going to go for 12 volt system, we will simply parallel all the 12 batteries together. So you see, it's going to be an issue for us, because the amount of current we'll be needing to charge these batteries in parallel will be an issue automatically. We should know that, because by the time you parallel 200 AH batteries in 5 places, the amount of current needed to charge them will be an issue. You understand? Discharging will also be an issue, because you're pulling the current together from this whole batteries. So I think it's better to go the 24 volts way. If we go the 24 volts way, then now we are left with another challenge. We have 5 batteries, and 24 volts will only group, if we are using a 24 volt system, we can only group our batteries in twos. You understand? If we group them in twos, that means, how do we do with a 5 volts with a 5 pieces of battery system? One battery will be left idle. So most at times, what I advise is, it's better to add up 1 battery to make it a 6 battery system. You understand? To make it a 6 battery. In that case, you see, you have given a tolerance for even additional load. When additional load comes in place, you have given it a little tolerance. We cannot say, okay, let's reduce it to 4. By the time we reduce it to 4, you see, we are going backward in our calculation. It will affect our calculation. It's better to go a little bit higher by adding 1 more battery. If we add 1 more battery, we have a 6 volt battery system. We have a 6 pieces battery system. Then we pair them in 2 to form a 24 volt system. So I will advise we go that way. Does somebody has a contrary view to that? Or a suggestion to that, sorry. Let me not say a contrary view, a suggestion or addition to that.
Rounding up the number of the battery.
Sir?
Don't come back. Rounding up the number of the battery is okay.
Yes.
Get more space for additional load.
Okay. That's fine. That's fine. So if we've done that, then it means hello? Or you have more to say?
No, I just wanted to you talked about you prefer an inverter with higher voltage.
Yes,
What
sir.
I've noticed is that you find out that the inverter size and the cheaper ones are always the ones that have less voltages.
The what?
That's why you find in the market the
Okay,
cheaper inverters.
okay, the cheaper inverter.
Yeah.
Okay.
Come upon products that you find, let's say, a 5 kVA inverter, you find out that the maximum number of volts is 100 volts. At the same time, you find an inverter with higher capacity that can take more voltages.
Yes.
So it's something I've noticed over time that the voltage is a factor in different brands in terms of its size.
Yes, sir. Yes. So that is actually you have said it all. You understand. The higher the voltage, definitely, obviously, the price will be higher. You understand, and cheaper inverters actually work with lower voltages. So that is that. Any other suggestion or addition? So now we have gotten two things. We have gotten our inverter capacity to be, for this particular case study, to be 24 volts, 1.5 kilowatt, 24 volts. And we've also gotten, if we're going for the lithium ion battery, we said we can just go straight to the market to get a 7.5 kilowatts, which is near enough. 7.560, 7.5 is available in the market. We can get it. Then if you're going for a lead acid, battery, please, one thing you need to look critically about is this depth of discharge for each battery. Types of batteries vary, you understand? So the depth of discharge will actually be a factor in your calculation to determine the number of batteries you're going to be using. So please, we should take that into consideration. Some have 0.5, some have 0.6, and some have 0.7 for lead acid battery. That's the depth of discharge. So it plays a key role in determining the number of batteries you're going to be using. So now, the next thing I would like us to look at is solar capacity. You know, if you look at these our topics, let me see. If you look at these our topics, we're almost doing the second topic, the second header, the second part. We're also discussing it in this first part. So in a nutshell, we're already doing two things at the same time. So now the next thing is solar sizing. I talked about, if you remember, there was a diagram I shared some time back that had to do with running out of time, God almighty. That had to do with
PV.
that have to do with PV. Let me see. Let me bring up the figure again so that we can see. And quickly, if we can talk about it the next time. Did I throw this figure? PV? Okay, yeah, I've seen it. Good. So let me quickly look at this. Can you all see it?
Yeah, it's clear.
It's clear, but can you see our? Good. So if you look at, we've talked about this thing before. We've talked about it. We use Nigeria as a case study because we said this is actually where majority of our concern is, where we do our jobs and other things. But it doesn't streamline to, it doesn't just only apply to Nigeria. Wherever you find yourself, you can always get this particular diagram and use it for your analysis and for your let me use the word, for your estimation and whatever concerning solar project. So if you look at, okay, let's look at Yola as a case study, or okay, Maiduguri is on the map here. Let's look at Maiduguri, for example. Maiduguri is on the map here. Maiduguri is in the red zone on this map. And it clearly says on this map that if you are in the red zone, and you have 1 kilowatt hour, 1 kilowatt solar capacity, 1 kilowatt solar capacity, and you are in this red zone like Maiduguri, you can get up to 4.8 kilowatt hour of energy per day. If you look at this, it's a daily counts. So if you are in Maiduguri, you can get 4.8 kilowatt hour of battery of energy generated in one day, as long as you have 1 kilowatt hour of solar setup. If you have a 1 kilowatt hour setup, you can be able to get 4.8 kilowatt of power. So in our own case here now, we have 7.56 kilowatt of 7.56 kilowatt of power as what we need daily. You understand? So what do we do? From our simple calculation is very simple. If one day will equate to 4.8 kilowatt hour. We also need to generate, okay, sorry. Let me not use one day. Let me use 1 kilowatt hour rather. You understand the point? 1 kilowatt of power, 1 kilowatt solar is what generates. We already know that we are working in Maiduguri now, using Maiduguri as a case study. 1 kilowatt hour will generate 4.8 kilowatt hour. Then what do we call it? Let me use arithmetics, secondary school arithmetics or primary school arithmetics. What will be the quantity to generate 7.560 kilowatt hour? So at least we all have small calculation background. We have small arithmetics background. So what capacity of solar do we need? It's very easy, you understand. It's just to cross multiply, right? 1 times 7 point this divide by 4.8. So it's very easy to say needed capacity is equals to 7.560 divided by
not seeing
what?
your work.
Okay, you're not seeing
on
it.
that.
Sir?
Yeah.
Yeah, try and switch
I'm
back
not
your
seeing
screen.
your
We're just seeing
calculation.
the map. We're not seeing your Excel sheet.
Okay, you're not seeing my calculation. Sorry. 1 minute, sir. Let me. Sorry. Can you see it now? Can you see it now?
Okay.
You can see it, right?
Yes.
Okay,
Yes,
sorry.
you can see it now.
Okay, 1 kilowatt of solar in using Maiduguri as the case study can generate 4.8 kilowatt hour. Are you with me? Then we want to look XXX or question mark is we need to know the capacity that we will generate 7.56 kilowatt hour. So needed capacity will be as simple as cross multiplication. We should cross multiply 7.56 times 1 divided by 4.8, right? So which is 7.560 divided by 4.8. So, which is equivalent to, let's hit the calculator fast. 7.560 divided by 4.8. I got 1.575 kilowatts. You understand? So 7.5 kilowatt solar is what will be able to generate this guy. So we can approximate it to the next this thing, the nearest that's 1 decimal place. Let me put it to 1 decimal place to be 1.6 kilowatt of solar. So you see, we've gotten what? Our solar capacity needed to generate this guy in what? in Maiduguri. So that is it. Are you with me?
Yes, sir. We're together.
Is it very clear?
Yes, clear. That means the number of
Hello?
the kilowatt, the summation of
Hello?
1.6
You're
kilowatt.
breaking. You're breaking.
It means we need solar panels up to
1.6 kilowatt. Yes, sir.
Thank you.
Yes, sir. That is the capacity needed to generate, that will be able to generate 7.560 kilowatt hour per day. So now, at least, I need us to do a recap because we have less than 2 minutes left. I need us to do a recap of what we have done so far today. We have actually, we've discussed about, because me, I want to go and watch Arsenal match today. So we have done a recap. We did talk about site surveying. We've talked about site survey, how the panels need to be installed for us to get the best out of it. We've talked about where we need to place our batteries, inverter and batteries, knowing fully well what these things can do or what they can emit or the heat they can radiate. We need to know where we need to install them so that it doesn't pose a risk of fire hazard or whatever. We also have done inverter sizing. We've done battery sizing, and we've also done solar sizing. Inverter sizing, we did it with the battery sizing. We did on the two major types of batteries available in the market, whether it's the lead acid or the lithium ion. So I believe, and we also went further to do the solar sizing, which we were able to get a figure using a particular load as a case study, right? So I believe with this, we are good to go for today, please.
Thank you very much.
So thank you. See you guys. Yes, sir. See you guys.
As the ball started,
It will soon start. It will soon start. 7 minutes.
Thank you very much, sir.
7 minutes.
All right.
Yeah, thank you very much.
Yeah.
Thank you.
after the
Done
match.
your match.
Thank you, sir. Thank you.
Thank you.
All
Thank you,
right.
guys.
Thank you, sir.
Thank you.
Thank you.
Thank you.
Bye.
AJ Kalibo.